Good morning and hello, my name is Graham King. I am doing a series of YouTube videos on my control panel from my solar. It's basically 5 solar panels, 5 charge controllers and 5 batteries. This is part 2. If you haven't seen part 1, that's the introduction to the system, which I advise that you watch. Now this segment is about the temperature gauges I've installed in my panel and the reasons why, followed by a video to show why I've installed these temperature sensors. These are the temperature sensors. As you can see, I got an external temperature gauge and I've also got an internal temperature gauge. At the moment this is reading 17.8 and this one's reading 18 centigrade. And before I go any further, I have now installed my new USB charger and I'm very pleased with that one. But let's get back on point. The reasons why I have stuck temperature gauges into my control panel. I made a video in 2019 which inspired me to do this. So without further ado, I will now show you the video, which is heavily edited. It's down to 10 minutes. I do apologise for that, but I hope it is of interest to yourselves. So let's crack on with it. These are the lights. These two work alright, that one's faulty. As you can see, 2 are working, 1 isn't. So let's take the covers off and expose what we're going to be looking at. This is the setup underneath the cover. You can see the bulbs are missing from the one on the left, and down there are the 3 switches for each one. The electrics are now exposed. As you can see, this is yellow. This one's yellow. But this one, as you can see, is starting to turn brown. This is the one that's faulty and is getting rather warm. So we're now got to do some temperature tests. Now I've been monitoring the temperatures. Now this one, 28.6, which is what it should be. This one, which is activated, is 48.5. I've been monitoring this and that's roughly what it is. But this one, 84.6. I've had it higher than that. 103.2. That's what's happening to that. You know, I am no electrician, but I know that that is not good. That's a lot of heat. Now would that catch fire? But it is in metal and it's rock wool insulation above it, so I would be very surprised, even with these temperatures, that it would catch fire. But more importantly, if you switch this on and off, you switched it on, didn't work, you're switching it on and off, and you inadvertently leave it on, and then leave your motorhome, caravan or boat, this would drain your batteries down. Unfortunately I'm not an electrician, so I don't know what sort of amperage this is drawing, but this is not the major problem with a fluorescent light becoming faulty. Yes, that is getting very warm, but this is on a 15 amp circuit. These wires are protected by 15 amp fuse. One major problem, 8 amp at 14 volts DC. At what point would this switch start to melt? Now if you notice, it's in a plastic. This is plastic. This switch, which is getting warm, is in a plastic. So if this starts to melt because that is drawing more than 8 amps, that starts to melt in the plastic tray right next to a vinyl ceiling which has got padding, thin ply and polyester installation in this area, would this be the start of a fire if this 8 amp switch was to melt and possibly catch fire? I don't know if it would catch fire, but the very point that this is melting, because it's drawing more than 8 amps from a 15 amp circuit, that explains why a 15 amp fuse will not blow. It won't blow until this deteriorates to the point that it would blow it, but between that and the fuse blowing, would my motorhome burn to the ground? Houston, I think we got a problem. Right, I have removed the light fitting from the ceiling. As you can see, there's rock wool up there, so I can't see that burning. But as you can see, we got vinyl, foam, polyester, and we got some sort of thin plywood, ideal kindle, with a switch melting here. Would this catch fire? And to be honest, I really do not want to find out, but I would say that's a hell of a risk. And yes, it is a possibility, especially when I've seen damage to an electrical harness. If this same thing occurred here, I cannot see this not burning. Is the earth, and that is the live. What I'm going to do now is I'm going to put a 3 amp fuse in here, inline fuse, and see if it blows at its current rate of deterioration. So let's do that next. Well, this is encouraging. That is a 3 amp fuse which has not blown. Lighting is 16 watts. Right, get in there. See, 16 watts, which is 1.3 amps power. So, but when you think about it, this is a faulty unit. That's getting very, very warm, of 100 degrees. We got a 3 amp fuse in here which has not blown, but that's on a 15 amp circuit. So if it's not blowing that one, it's definitely not going to blow a 15 amp. And I suppose the question is, with this being faulty, is it going to catch fire? Okay, taking the test a bit further, as the 3 amp fuse has not blown. This is getting up to 110 degrees now. So I've set up my amp meter to see what amps we are exactly pulling. As you can see, it's 1.35 amps, which has surprised me, to be honest, because that's what it should be drawing. And yet it's faulty, but only drawing 1.35 amps. So I'm very pleased that I've done this test, because that has surprised me. You can see it's into the 10 amp DC. So you learn something new every day. But why that's getting up to 110 degrees on the supply of 1.35 amps at 12 volts, there you go, I've learned something new. Okay, I am now doing another test, a surge test. I want to see if there's any surge when we apply power. Now I've set it up with the meter. Now for those of you who thought, well, why didn't I use the meter in the first place? That's because I did not know how much amperages this was consuming. And my meter only goes up to 10 amps. I didn't want to destroy my meter before I'd established roughly what was going into this light unit. So we've got it set up, it's on 0. I'm now going to apply power and let's see what it does. That is what it is consuming at the moment. It's 147.48. Yesterday it was constant 135. So it looks like it's deteriorating a bit more today. I think when you shut these things down, it cools down, then you switch it back on, it starts heating up. It deteriorates faster. So the draw of this unit is increasing according to this meter and the measurements I took yesterday. So I might even repeat this test tomorrow. I should leave this for about half an hour, let it warm up, and then turn it off, and then tomorrow repeat the test. See, we're on 149 now. So it's definitely increasing its consumption. And see what it measures tomorrow. So it's 149. So that's a slight increase from yesterday. Like I repeat again, I'm doing this test with a 3 amp inline fuse. Okay, this has been going for about 15-20 minutes. The amperages are staying roughly the same, 147. Remember, it was 135 yesterday, so it's definitely drawing more power. So let's see what temperature we are getting today. 109. So it's definitely getting warmer than yesterday. So this unit is definitely deteriorating as it goes. So obviously turning it off, letting it cool down, then starting it back up, it is deteriorating. So as it deteriorates, it's going to pull more power and it's going to get warmer. You know, another check on that, 146. Now this is turning out to be quite interesting and I'm learning quite a bit. So to conclude on why I have temperature sensors in my control panel is for this very reason. You know, I still got it. You can see how badly burnt it is, you know, and I caught this early. So if you have a failure, an electrical item that isn't working, disconnect the power because the power is still going to it. And this would have drained down the battery. Would it have catch fire? Possible. The fact that it's got an 8 amp switch on a 15 amp circuit, that increases the odds. That's not good. And you think this is a manufacturer that built this. So that's the one reason why I'm doing that. The second one is this. As you can see, that's badly melted. When we brought this boat, after 55 hours of use, we lost the alternator. Well, the alternator light come on, it wasn't charging, and that's the reason why. And when I examined all the components, this is what I found. Now this is a 140 amp isolation switch. Now this is a 140 amp hour switch, which is fine for a 100 amp alternator. But this was uprated, on this boat, was uprated to a 240 amp alternator. So when you stick 240 amps for a isolation switch that can only handle 140, that's the result. Of course, the manufacturers, it's not our fault. It was the previous owner. And the previous owner brought this as a shell and fitted it all out, never used it, and I brought it. So he denies, you know, this fits the hole in their battery case. A 300 ampere wouldn't fit in the hole. Then they tried to blame the inspector who inspected the boat. He should have spotted this. And it's like he said, they rely upon manufacturer's conformity. Well, if they get it wrong, you know, the inspector thought this was the correct size. He doesn't check individual items. So there, and this has been classified as a near fire. And you know, electricity, you know, you don't mess about with that stuff really. And I've done this one in my first video. I brought 5 of these. These are to control the solar panels, protect the solar panels. I lost 2 in the first year. And interestingly, I can't take it apart because this screw is obviously melted. This must have overheated before it won't work no more. You know, the item, this still works, just, but I presume that must have overheated. The third item is, this is my battery pack that I use for testing equipment. I don't want to install it and then find out it's not working, so I use this. You know, this comes from an e-bike and it's 12.8 volts. And we've got a breaker. So I turn this breaker on, hit the power, cuts it off. Now, turn it back on, but we'll just use one strand. If you can see that, get that. I'll just use one strand. Right? It works. Now, if that was fitted to that, would it have tripped it out? I think it would. I think you should ditch blades and replace them with breakers. You know, replace everything with breakers. You're protecting. You're stacking the odds in your favour. Now, the final reason for putting temperature gauges into my control panel is the fuses. Is blade fuses. This is a 10 amp blade fuse. Now, when you're fusing a cable, there's a rule, 20% rule. You don't. So basically, if you're drawing 8 amps off a circuit, and obviously the cable can handle that, you would protect it with a 10 amp fuse. So there's a 20% rule. If you start going over that 20%, this gets rather warm. I know that from personal experience. When you draw too much power, when you're getting up to the limits of a fuse, it starts getting warm, you know, because when you think about it, this fuse has to blow. So it's got to have more than 10 amps for it to go. The other reason for sticking temperature gauges into my control panel, these are EP Ever 30 amp charge controllers. Take note that the 2 fuses are 30 amp. So where's the 20% rule? So if anything was to ever go wrong with any of this, all these switches, because down here we got a 25 amp protecting the solar, and we got a 32 amp protecting the batteries. So if any of these started to melt, malfunction, or anything on this circuitry board started to go wrong, then the internal temperature gauge will far exceed the external temperature gauge. That's it from me for now. I hope you've enjoyed this video and it's enlightened and gave you some food for thought. My next video is about my battery bank, because I've used no cables, I've used aluminium buzz bars. Yes, it's different, and it's been working for 18 months, no problem. So that will be a lot shorter video than this one. And so until next time, TTFN, and have a nice day.